Well, I hope you guys had an enjoyable weekend. You're probably going to be watching this during school if I had to take a guess. And, consider yourself lucky you're not where I am, cleaning at the racetrack. One of the wonderful things you get to look forward to in high school, I suppose. We have finished chapter 1, and we'll be starting on chapter 2. And this chapter is on equalities, inequalities, and problem solving. So pretty much solving equations, and then problem solving is just a nice way for them to call word problems what they're not. So just to give you an FYI and a heads up, chapter 2 is going to be covering word problems, so you can mentally prepare yourself for that now. All right, so this chapter gets you started with the properties of equality. So the first one we're going to be looking at is the addition property of equality. And you can't really deal with properties of equality unless you can concretely define what an equation is. So an equation is, I've said this before, anything that contains an equal sign. Expressions are not equalities. So right here on the left are some examples of what an equation would be. There's an equal sign in each of these. And on the right, what you see are examples of expressions. Expressions are on either side of an equal sign, but they are not an equation in and of themselves. So 7x is an expression, and 6x plus 4 is an expression. What makes this an equation is this equal sign right here. So the addition property of equality. The addition property of equality pretty much says that you have to do the same things to both sides of the equations with addition. So you can add something to one side so long as you add it to the other. It doesn't matter what it is, and it won't change the value. So it starts off by defining what a linear equation with one variable is, right? And that's written in the form ax plus b equals c, right? Where x is your variable in this, and a, b, and c are all coefficients, or are all numbers. Okay. So using the addition property to solve equations, right? So if A, B, and C all represent numbers, and A equals B, then that means if you add C to both sides, it's going to be the same equation. So if A equals B, then A plus C equals B plus C. In the same way, you can use subtraction, right? Subtraction is just the opposite form of addition, so it falls under the addition property of equality as well. All right, so if you had to solve for the equation, if you had to solve for the equation of x minus 4 equals 7, using the addition property of equality, okay, what that's going to look like is that means you have to add something to both sides. So what you want to do when you're solving equations is to get the x by itself. All right, so in getting this x by itself, what you're going to add to both sides is going to be a positive 4. Because x minus 4 and plus 4, so minus 4 plus 4 is going to equal 0. And you have to add that 4 to both sides, which will end up with x equals 7 plus 4, because these cancel out. So your solution to this problem would be x equals 11. All right. So that's very simply what the addition property of equality says, is if you add something to one side, you must add it to the other. So you add a 4 to this side, you have to add a 4 to that side. So think of the equal sign like a balance. And with an equation, you're always wanting to keep that balance in place. So if you add anything to one side, you have to add it to the other. So if you're going to keep that balance in place, okay, so if this is your balance and that's your equal sign, all right, and you have your scale here, your equal sign in the middle is your pivot point. If you're going to add a 4 to this side, you have to add a 4 to this side. All right. If you wanted to, for some crazy reason, add a 1 to this side, you have to add a 1 to that side. All right. It's not going to do anything. You have to keep doing the same thing to each side. If you do one thing to one side of the equation, you must do it to the other. And the next thing we're going to look at is the multiplication property. So if you multiply something to one side, you have to multiply it to the other side. So you can pretty much do whatever you want with equations, so long as you do the same thing to both sides. So simplifying equations. Whenever we see simplifying equations, you guys know what that means. It pretty much just means to solve it. So in this example, you have a 6x plus 8 minus 5x equals 8 minus 3. All right, so the first thing you need to do if you're simplifying an equation is you need to combine like terms. All right, so you have to look at each side of the equation and find the like terms. So in this situation, you have the x's, all right? These are like terms because they have the same exponent, okay? So there's no difference in any number up here, all right? So these are like terms and you can combine them. So 6 minus 5 is going to be an x plus 8, all right? Now you go to the other side of the equation, okay, over here, and you have like terms over here, and you are going to add your like terms over here of an 8 and a negative 3, which is going to be a 5. Okay, so now you can go back to your original equation with your simplified form. Okay, and you have an x plus 8 on this side of the equation equals 5. All right, now you need to get the x by itself in order to solve. So you're going to subtract 8 from both sides, and you get x equals negative 3. Okay, so you have another one. You have 3x inside the parentheses 3x minus 5, and you're multiplying that entire thing by 3. All right, and that is going to equal a positive 10x. All right, so your first thing, order of operations, is you can do the inside the parentheses. There's nothing you can combine here, so you're going to distribute. All right, so in distributing, you need to send this 3 through to both parts of the interior parentheses. So 3 times 3 is 9x minus 3 times 5 is 15 equals 10x. All right, then you need to look for your like terms and get the x by itself. All right, so you have an x here and an x here. So you're going to want to subtract the 9x from this side and 9x from this side, which would give you a negative 15 equals a positive x. Okay, and that is going to be your solution. All right, some of you might ask, well, why can't you just add the 15 to both sides and subtract the 10x? You can do that, but you would still get the same solution, because what you would end up getting is a negative x equals a positive 15. Now you need to get this negative sign to both sides, so you multiply each side by a negative 1, you get x equals 15. You would still get the same number. Okay, but don't do more work for yourself than you have to. Okay, fastest way to do it would be to subtract the 9x from both sides. All right, this is just different variables. Okay, don't get freaked out just because you see something besides an x. So you have 4p minus 11 equals 2 plus 2p minus 20. Okay, now you're going to want to combine your like terms on each side of the equation. So these are like terms on this side of the equation. So 4 minus 1 is going to be 3. Okay, equals, find your like terms on this side of the equation. And that's going to be negative 18, because 2 minus 20. Okay, now, like I said before, don't make more work for yourself than you have to. What do you want to subtract from each side? All right, you want your p to stay positive. It'll make your life a lot easier. So I would subtract the 2p from both sides. And you get p minus 11 equals negative 18. And then add 11 to both sides. Okay, and you would get p equals a negative 7. Okay. All right, same deal with this one. This one, the slide's going to walk you through. Okay, so you have 5 times 3 plus z equals minus an 8z plus 9 equals negative 4z. First thing you're going to do is distribute, right? So you distribute this 5 through and you distribute this negative through. So you get a negative 8z and a negative 9. All right, then you combine your like terms. So you get 6 minus 3z. All right, add the 4z to both sides because you want the z to stay positive. You get 6 plus z equals 0. Subtract the 6 from both sides, so z will equal a negative 6. All right, writing algebraic expressions. These are word problems. Okay, that's what they mean by this. So the trick with word problems is to ignore anything that's not important information. All right, so the first thing you're going to do is you're going to want to take your word problem and you're going to want to find the numbers. All right, find numbers and find any variables that it tells you have to have. So the numbers here, all right, you got 60 feet shorter than, okay, so the Golden Gate Bridge, 60 feet shorter than the Narrows Bridge. So if you have the length of this bridge as m, how would you express the length of the Golden Gate Bridge? All right, so you have m is the length of the longer bridge. Golden Gate Bridge is 60 feet less than the other one, so m minus 60. So the Golden Gate Bridge is m minus 60 feet long. All right, so this is just a random application of what they just covered, but in a word problem. All right, so this is combining what you learned of word problems from chapter 1 and combining what you know of making the equations balance and the addition property of equality that we just covered here. All right, so it might get a little bit more complicated, but don't let word problems freak you out. In a lot of situations, especially with this text, the first sentence is not even important information. It's just some kind of superfluous information that makes the word problem appear to be more interesting. All right, so find what your number is and write that down, and then find anything that tells you for a variable, and then read the sentences that they're kind of embedded in, because that's what will give you the information. All right, so you should be all set to move on and work on some problems. It's doing this within class on Monday probably, because I'm not going to be there. So you have some problems that you can work on in class. You can get this started, and you can get started on the notes and the example problems for this lesson in class today, which hopefully, if you manage your time well, means that you shouldn't have any homework tonight. But if you didn't finish this in class, you will have to finish this for homework, okay? So hope your day went well without the high school there, and good luck with the homework tonight.